So this kind of question we can expect in the end semester examination. Here the relative permeability and permittivity of the medium is given, epsilon r and mu r is given, and the field intensity of the plane wave is also given. So let us write down on here the given data. Epsilon r 8 and mu r 2, and expression of the field propagation is 0.5, it is a magnitude, and sine 10 power 8 t, sine 10 power 8 t minus beta z and AZ indicating that this wave is propagating along the Z direction. This wave is propagating along the Z direction. This represents the direction of the propagation. So as the wave propagates through the medium, so what will happen? The phase will also change. So there is a phase shift. So here we can see that the beta. So beta represents the phase shift. And phase shift happening as this wave is propagating along Z. So that's why the phase shift is multiplied with Z. Now if you see the general form of the sinusoidal wave, we usually represent it is like this: sine omega t. So here, where is it? Omega. So this one is omega. This is the velocity of the wave. So omega we can write down as, from here, this expression, omega equal to 10 power 8. So in terms of frequency we can write down omega as 2 pi f equal to 10 power 8. So omega in radian per second, but whereas frequency is in cycles per second. So let us find out what is the frequency. So f equal to 10 power 8, which is upon 2 pi. Ten power 6. So which comes around 15.91 10 power 6 megahertz. So this is the frequency. Now we are going to calculate the intrinsic impedance. It is expressed as square root of mu by epsilon. So we know that mu equal to mu naught mu r, and epsilon is equal to epsilon naught epsilon r. The value of mu r and epsilon are given. If we put it into the formula, so we can write it down as where mu naught and epsilon naught are constant. If we simplify this expression, we can write down as 125 times the square root of mu r and epsilon r. If we check back, the mu r is 2 and epsilon r equal to 8. Mu r equal to 2, epsilon r equal to 8. If we substitute these values, the intrinsic impedance becomes 125 times square root of 2 upon 8, which comes around 65. Now we are going to calculate next paragraph. So now we are going to calculate the wave velocity. Wave velocity. What is the velocity with which the wave is propagating through the medium? That is the meaning of wave velocity. So this can be expressed as 1 by square root of mu and epsilon. The same as way of before, so we can bring into the expression of mu, is mu naught mu r, and epsilon naught here. And we can write down the expression of the velocity of light. Mu naught is mu naught epsilon naught. This is the expression of velocity of light. So the same thing we can modify as, so velocity of light is upon the square root of mu r and epsilon r. So then we will get what is the velocity of this wave. So this velocity of this wave is the light velocity 8 times 10 power 8 upon mu r and epsilon r. So mu r and epsilon r 2 and 8. So 2 times 8. If you use the calculator, you can find the value of the wave velocity, which comes close to 75 times 10 power 6 meter per second. So if you compare the wave velocity of this electromagnetic wave in a medium is much lesser than the light velocity. That this formula we can use to connect with the phase velocity and the wavelength. So let us see that what is wavelength. There is a popular formula which defines the relationship between the frequency, wavelength and velocity of any electromagnetic waves. So which is F lambda, mu equal to F lambda, very popular formula. So from this expression we can find out the wavelength lambda. So wavelength lambda is mu by F. We know that mu, it's the velocity 75 times 10 power 6. And the frequency. The frequency is 15.91 into 10 power 6. .91 megahertz. 10 power 6. So the lambda becomes 4.71 meter. This is the wavelength of the electromagnetic wave. So if we measure the distance between two adjacent crest or trough, that is the wavelength. So which comes around 4.71 meter. So there is another formula which connects the wavelength and the phase shift constant. So beta equal to 2 pi by lambda. This is very important. The phase shift constant, the formula, the expression which connects the phase shift constant and the wavelength. So here, so beta becomes 2 pi by wavelength is 4.71. So beta comes around 1.33 radian per meter. That means for 1 meter of the distance traveled by the wavelength, we produce a phase shift difference of 1.33 radians. So that means, see this one. This is the electromagnetic wave. As it propagates in the Z direction, what will happen? There is a phase that decreases. So here we can see that, see, this is the lambda, but here we can see that lambda is slowly changing. So the changes of this, the wavelength is represented using this beta. This is a phase shift constant. The phase is shifting. So finally we obtain the old expression which is demanded in the question: the wave impedance, the wave velocity, and the phase constant. That is beta.